So in this problem, we need to obtain the ratio of the sum of the first n terms of a GP to that of the sum of the terms from n plus 1th term to the 2nth term. So let's begin. So we'll first begin by considering that let there be 2n terms present in the GP with a first term denoted by A and a common ratio given by the letter R. Now we need to find out the value of A1 plus A2 all the way up to the nth term divided by an plus 1, an plus 2 all the way up to the 2nth term. So let's begin. So our first term, so that will be simply A. Then our second term will be A times R. The third term will be AR squared, and this goes all the way up to the nth term, which will be A times R raised to the power of n minus 1 divided by the an plus 1th term. So this is going to be A times R raised to the power of n, followed by n plus 2th term. So that will be A times R raised to the power of n plus 1. This goes all the way up to the 2n term. So we have AR raised to the power of 2n minus 1. Now, since it's given here that there are 2n terms and all of them are in GP, so that would mean we can use the sum formula. So applying the sum formula, the sum up to n terms of the numerator, that will be the first term A multiplied to the common ratio. The common ratio is going to be R raised to the power of n minus 1 whole divided by R minus 1. And then in the denominator, we are going to have AR raised to the power of n. So this is going to be the first term multiplied to the common ratio. That's still going to be R raised to the power of n minus 1 all divided by R minus 1. So here we will see that we are finally left with the value 1 divided by R raised to the power of n. So the ratio has a value 1 over R raised to the power of n.